So, the saving grace of my shelter in place. I'm lucky enough to live within walking distance of this little creek, a secret spot where my son and I have taken refuge when I force him to let go of the Legos and get outside. Hiding under a log next to a mini waterfall, pretending to be talking rabbits. You know how it goes. One day we came back to our spot and the waterfall was gone. A bit of rain had fallen in the hills and the creek had completely changed paths. So we got to work. Digging through the deposition, we moved sand and sticks and re-established a trickle like mischievous beavers in reverse. And a few days later, it had changed again. Which got me thinking about the watershed. So little rain had fallen, yet so much had changed. How? How much land drained into this creek, and what's its shape? How many little tributaries? So we went home and played some more. Want to play too?
So you start with just crinkling your paper up into a bowl. This wad would be great. Then you can uncrinkle it, find an end, and should be another end, and then you can just pull it, kind of. But instead of like trying to flatten it out or something, try to make, once it's all like, make a tent or something. Make kind of like a mountain. Then we're gonna use blue to trace where we think the water is gonna pool up. And you can make a little circle.
Nice. Where do you think the water would flow on this side of the mountain?
Well, it would probably go here. See, if you don't want it to like run off onto your floor, I would recommend just pinch it up like I was saying.
So did the water flow where you expected? Check out your ridgelines and the slopes that they bound and the creeks in those areas. Each area that drains water into its own creek system is its own watershed. Do any of your watersheds come together and drain into a larger body of water? Did any ponds or marshy areas form lower down on your mountain, where it meets the coast, or the border of your paper? Moving to something a little more substantial than paper, an actual mountain. The lower slopes of Ben Lomond Mountain and the southern Santa Cruz Mountains. Looking at this aerial image, can you see where the watersheds might be? How about now, with a terrain map showing ridges and slopes? You've probably guessed that the little red shape is UC Santa Cruz. In this video, we're going to explore some of the watersheds on campus, their locations, the pathways of their drainages, and some of the plants and animals that call them home. Zooming into the campus, what do you notice about the darker-looking, lower areas on the map? Do you see how they are oriented pretty much north-south along the mountain? This indicates the general direction, or aspect, of the lower slopes of Ben Lomond Mountain here. This next map is a topographical map, where all the squiggly lines represent the slope and shape of the land. Each line connects dots along the same elevation, so if you rode along one line, you'd always be at the same height above sea level. Hit pause now and use your finger to trace along a single line. Then trace where you think the main drainages are, where you think water would flow. Click that unpause when you're done and let's get on with it. The drainages look like little upside-down V's, and you can see 3 main drainages, or ravines, passing through or alongside the campus core. A housing project environmental impact report showed 8 watersheds draining campus lands. In this video, we'll focus on 3 of the most obvious, moving east to west through the middle of campus. Let's trace the length of Jordan Gulch. The headwaters are up in the seep zone, an area of permeable soil underlain by impermeable bedrock, where there are numerous seeps and springs. There are 2 forks in the upper part of the drainage. The western fork lies within a ravine that passes between Science Hill and Colleges 9 and 10 to its confluence with the eastern fork east of McHenry Library. The Eastern Fork also starts in the seep zone and leads down between colleges 9 and 10 and Chinkapin Road by Crown. It joins the Western Fork below Hahn Student Services in McHenry and leads down a narrow ravine down to the village in the lower quarry, reappearing briefly by the start of the bike path. Let's take some little walk snippets through the seep zone to the headwaters of Upper Jordan Gulch's East Fork. It's a mix of redwood and mixed evergreen forest with small seasonal waterways that only flow during and right after rain events. This is the start of the actual ravine. Moving up towards the headwaters, there are a few trickles and fairy swimming holes. Check out the orange iron oxidizing bacteria, funky little yucky dudes that do chemosynthesis by oxidizing dissolved ferrous iron. Cool. And then we arrive at the headwaters, lush with ferns and sedges. Further south, under McLaughlin Road, we see how the drainage is dry within the Redwood Forest Canyon. But why? Let's see if you can figure it out. For the next minute, write down what you know about what you're seeing. Do you recognize these things? Or these places? As you may know, UCSC was a working ranch from the mid-1800s through the mid-1900s. For the first 50 to 70 years, the primary industry was the production of lime, a pre-cement building material that helped build California through its major growth following the gold rush. Marble rock, which is metamorphosed limestone, itself dead sea creature shells from nearly 200 million years ago, was mined from several quarries on what is now the campus. The rocks were burned in kilns, and the campus's forests were clear-cut to feed the kilns. But what does this have to do with hydrology? Well, have you ever heard of or been in Empire Cave? Marble bedrock dissolves with acids naturally found in rain and groundwater and can form into what's called a karst landscape. Karst is characterized by subsurface flows, caves, and sinkholes. Seen any of those? There are old ones, some of which trap water, and new ones too. In fact, there are a ton on campus. This one is actually called a swallow hole, since it occurs in the stream course itself. This is one of the places where the water heads underground. Moving on to the west, to Moore Creek, whose headwaters are also in the seep zone. Like Jordan Gulch, there are also two forks to the upper section of this drainage. The western fork runs down a redwood forest ravine between Kresge and Porter and Heller Drive. The eastern fork begins below the Core West parking garage and heads between Heller and Performing Arts, getting swallowed by a swallow hole along the way. Both forks are dry except during rain events, and they both end in sinkholes right above Meyer Drive, the road that goes to the music center. The water mysteriously pops back up in the ravine below the Oaks Path, where it passes into a willow-dominated, more open habitat within the grassland affectionately known as Lower Moore Creek, through the old Cowell Reservoir, now known as the Arboretum Pond, under Empire Grade, and off campus. Check out how it goes through Moore Creek Preserve, gathers water from another tributary, passes down through Antonelli Pond near the coastal campus, and then through Natural Bridges State Park, where it sometimes ponds up, sometimes makes it through tourist tows to the sea. Here's another view of its course on campus. I don't have much footage of this drainage right now, so let's feast our eyes on some animals that like to use Lower Moore Creek. This section has at least a little bit of water year-round, and the animals know it. This was in winter, though, with higher flow. A cougar or two pass through occasionally. This riparian or streamside strip of vegetation is an important corridor for them and other wildlife passing from the grasslands that dominate the southern slope of the mountain and the forest to the north. In the Arboretum Pond is an isolated breeding site for the federally threatened red-legged frog. Its tadpoles prefer the sunnier zones, so we're getting permits to thin the willows that have enclosed the pond. Moving west again, we arrive at Cave Gulch. The drainage starts in the Seven Springs area, home of the Forest Ecology Research Plot. Here several springs coalesce into three main headwater streams, which come together on the FERP and head down the steep Redwood Ravine next to Empire Grade. This is one of the only places on campus with year-round water, at least until you approach the stretch by Empire Cave. Upstream from the cave, the stream dives underground, popping out further downstream in Wilder Ranch State Park, where it seeps from the stream bed and bubbles from stream banks among the tree roots. The drainage then meets up with Wilder Creek before heading down the slopes and eventually into the ocean at Wilder Beach. You can see that this watershed is a lot bigger than the others, and the streams are too, relatively speaking. Here's another quick view with an aerial photo base map. Aren't maps cool? Heading back up to the headwaters, here's the FERP in winter, with a spring channel flowing past a phenology litter trap, where we're studying seasonal change by inventorying everything that falls from the forest canopy. These folks migrate here from upland sites to breed in Cave Gulch when the rains begin. Further down the drainage, a tributary stream just above the north perimeter parking lot heads from the western edge of the seep zone down into Cave Gulch. Down in the main drainage now. Hey, it looks like an actual stream. Empire Cave is an obvious and all too accessible karst feature within Cave Gulch. Perched just above the present-day stream, this cave formed deep underground and was uplifted as the Santa Cruz Mountains rose up. It's home to rare invertebrates, some of which have never been found elsewhere on Earth. Here, unless it's rained recently, the stream flows below ground. But then, like the mysterious miracle water is, it pops back up. Amphibians appreciate this. These two salamanders have aquatic larvae that call Cave Gulch home. Finally, with all the disappearing and reappearing water on campus, it's helpful to have other ways to know water is around. Plants can help, as some are adapted to having wet toes. I'm going to shut up now and let you take some notes on these plants. For each species, write down one dominant characteristic you notice that will help you recognize it the next time you're out there. Maybe the edges of the leaf are wavy, or the leaves are heart-shaped and toothed, or shaped in some other way. Just find something that seems distinctive to you, and feel free to sketch. In our next video, we'll meet Courtney Trask, Campus Stormwater Programs Manager, to see how our built campus and these waterways intersect. See you in the watersheds.